everybody. In this video, we're going to talk about how to compare or order decimals. So there's several different methods that you can use while you're teaching your students about how to decide which decimals are bigger or smaller than each other. So the first method, the 100 square method, really only works if you have decimals that are either 1 digit or 2 digits long, or in other words, if they have tenths or hundredths. So the idea of the 100 square method is you have a square that represents a whole, and then you split it up into 10 pieces. And so you say, okay, if I split up this square up into 10 pieces, then each one of these pieces is a tenth. Then if I split up each one of those pieces up into 10 pieces, then it will create these littler squares, and each one of those will be a hundredth. And so you say, okay, well, if I have the decimal 0.7, well, that means that I have 7 tenths because the first decimal place value is the tenths place value. And so I'd say, okay, well, here's 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, and 7 tenths. And so basically this space that I've shaded in blue, that would represent the decimal 0.7. And then I would say, okay, well, what about if I have 0.23? Well, the 2 is in the tenths place, so that means that I will have 2 tenths. So there's 1 tenth and 2 tenths, and then I'll have 3 hundredths. And when you draw a picture of the decimals like this, it's really easy for the students to see, well, in this case, 0.7 is going to be the bigger decimal. And so 0.7 is greater than 0.23. And I guess technically you could do more decimal place values if you imagine like cutting up this piece into 10 littler pieces and then cutting those up into 10 pieces. But really the 100 square method works best if you are only working with decimals that are either in the tenths place value or the hundredths place value. The next model for helping students order decimals is the number line method. So on a number line, we can plot our decimals just like we could plot any other fraction, because decimals are just special types of fractions that have denominators with powers of 10. So if I wanted to graph the number 0 and 7 tenths on the number line, well, I would first need to split my distance between 0 and 1 up into tenths. So I might say, okay, well, here's 10 little sections there. Hopefully I did that right. And if I have 7 of them, I'll go 1, 2, 3, 4, 5, 6, 7. It looks like I did do it right because I have 3 more spaces. So this is the point for 7 tenths. And then if I have 23 hundredths, well, the 2 is in the tenths place. So I'll go 2 tenths. And then I need to go 3 hundredths. And a hundredth is a tenth of a tenth. So if I imagine splitting this up into 10 little pieces and I go 3 of those pieces, then that shows me that the decimal 0.23 is going to be about there on the number line. And again, this is a visual way of showing your students that 0.7 is greater than 0.23. And one of the common misconceptions that students will often think is they'll think that this is the bigger decimal because it has more numbers in it. And if you think about it, that actually is a reasonable misconception, because when we were working with whole numbers, that was true. If you had more digits in your number, that meant the number was bigger. But when we're working with decimals, that's not necessarily true. And so that's one reason why it's really important to show your students visual reasons for why decimals like 7 tenths are bigger than the decimal 23 hundredths. Another method you can use to help students compare decimals is the fraction method. So the idea of the fraction method is to write the decimals as a fraction. So 7 tenths would be written as 7 tenths, and 23 hundredths would be written as 23 hundredths. And we know from our work with fractions that you can't compare two fractions unless the denominators are the same, because the denominator defines how big the pieces are, because it tells you how many pieces the whole is cut up into. So like these hundredths that we have here are much smaller pieces than the tenths, because if you have 100 pieces in a whole versus 10 pieces in a whole, the tenths are going to be much bigger because the whole wasn't split up into as many pieces. And so you'd say, okay, well, what's the common denominator between the two? Well, the least common multiple of 10 and 100 is 100. And so to make 7/10 into hundredths, I would multiply the top and the bottom by 10, which means that this is equal to 70 hundredths. And when you write it like that, where you have common denominators, it's obvious that 70 hundredths is more than having 23 hundredths. And so again, 0.7 is greater than 0.23. So that's how you would use the fraction method. And then the last method is the place value method. So I'm going to do the same two decimals that we've been using on the previous slides. So we have the decimal 0.7 and 0.23. And so with the place value method, what you do is you look at the largest place value first. So you say, okay, well, the largest place value in this case is the ones place value, but both of these numbers have the same amount in the ones place value. They're both 0. So then you go on to the next place value and you say, okay, well, is one bigger than the other? Well, in this case, 7 is bigger. And so we would say 0.7 is greater than 0.23. And the reason why this works is because if you were to visually think about what this looks like, well, 0.7 would be 7 of these blocks, and 0.23 would be 2 of those blocks and 3 of these blocks. And it doesn't really matter how much of the smaller blocks you have if you have a bigger number of the big blocks. And so this is why you can use the place value method and just look at the biggest place value until there's a difference. And sometimes you might have numbers that are very similar up until a later place value. Like, for example, if you were comparing the numbers 0.123 and 0.127, well, in this case, they have the same ones place value and the same tenths and the same hundredths, but at this thousandths place value, that's where the difference is, and 7 in that case would be bigger. And so that would tell us that 0 and 127 thousandths is greater than 0 and 123 thousandths. So those are some different strategies you can use to order decimals, and there may be multiple decimals. So in this example, I was just comparing 2 decimals to each other, but sometimes you may have like 5 decimals and you need to order them from least to greatest or something like that. And in that case, all of the methods will still work. You'll just have more models that you'll be drawing pictures of. So if you have any questions, let me know, and I hope you guys have a great day.